Welcome, I'm Kamau Jenga. I'll be taking you through various concepts and theories of the engineering world, things that we interact with each and every day, how they work, and problems you may solve yourself, and maybe ideas of your own. You can have ideas of your own. So today I'm taking you through the starting system. Is a module that I've prepared for you. I will take you the various components. Is the battery, is mainly a source of current, is a fuse, switch, our relay, our park or neutral switch, our clutch start switch. Then we have a start motor. Then we have the connecting wires. So let me switch it on, see if it works. So I have to switch on the park neutral switch. Yeah, it works. I'll show you. So it connects with your engine and rotates it until your engine can start by its own and rotate by its own. Yeah, so take you through how the different components work, the wiring, and we'll be able to learn by the end of the lesson how the problems that may occur or you may encounter. So the problems are mainly when your starting system is the problem. There are other things that might cause your vehicle not to start, but when it comes to the starting system, we'll be able to have quite an understanding of what may be wrong. So our battery is a source of current, and current flow is from our positive towards the negative. So from the positive towards the negative, from the positive towards the negative. So we have three current paths. Let me show you the first one. So if you follow this one from the positive, follow this one into your switch, follow the blue wire, follow the yellow wire into your relay, then in back to the negative or the earth. So let us draw it. We have a battery. This is the negative, this is the positive. We have our fuse, then we have a switch, then we have our relay. So from the battery to your fuse, then to your switch, then to your relay, then back to the negative. That is our first current path. So from the battery to the fuse, our fuse is mainly for safety purposes. It burns or blows when there is a fault in your system, maybe a short, and there is quite a huge amount of current that is passing through. It blows here we're using a 15 amperes fuse, so not more than 15 amperes of current will pass through this one for safety purposes. Then into your switch, as it is pre-loaded, immediately you release it, it comes back to its original position. This is also for safety. When you cranking your engine and now the engine starts rotating by itself, it rotates at a much higher speed compared to your starter. If they continue rotating together in the engaged position, your starter may come to a destruction. It is not made to rotate at that higher speed, so it may cause problems to your starter. So immediately you release the ignition switch or the ignition key, it comes back to its original position, switching off the starter, and your engine rotates by its own. Then we have a relay from the switch to the relay. Our relay is type of an electrically operated switch. So what do I mean? We have a mechanically operated switch. I have to use external force to operate the switch, but for our relay we use current to operate the switch. So you can see see when I switch on, I am allowing current to pass through it. Yeah, so let me show you how it looks like inside. So we have a coil, then we have contact points. So from our battery positive, current comes in, and here there is a coil. The coil magnetizes when it is energized. The coil magnetizes and pulls this contact point. It closes, so it allows us to use a lesser current to switch on a much higher current. So from your battery back to negative. Yeah, let me show you. So here's our coil. When current passes through it, it magnetizes and pulls the contact point that way. So a relay is used to switch on much lesser current. To switch on a much higher current using a much higher current using a much lesser current. Then this can be your load. Hope you can visualize it. So it has two parts: the electromagnet and the contact points. Yeah, so you can see So the first current path passes through the contact point and back to your battery. Yes, battery. So your load can be your starter, can be your fuel pump, it can also be your cooling fan, it can also be your headlight. So the relay can be used in electric circuits to switch on your starter, your fuel pump, your cooling fans, and headlights, and also other loads. Maybe you can have an idea of how you can use a relay to power a load. So why we do this is because when you are cranking your car, or maybe you're using these components, it requires a much higher current. Maybe when you, for our case starting, we require from 100 amperes to 500 amperes depending on the weather condition. So if it's cold enough, we require much greater current to get your engine cranking. So if this higher current passes through our switch, if we are to wire it directly and from this way, if we are to wire it directly, when this much higher current passes through your switch, it may heat up your switch, causing your switch to melt and burn up. So that is why we use a relay. We use a lesser current to switch on that higher current. So for our case, I'm using a 4-pin relay. We have our coil there, then we have contact points. Take these as our terminals. So for our coil, it is normally labeled 86, and this side 85, this side 30, and 87. So it is to your load, that 87 is to your load, 30 is your power supply, 86 is from the ignition, and 85 is back to negative or ground. So this is basically how we wire our relay. Hope it will not be a problem now. Yes, so from our battery to our switch to your relay, the coil side, then back to your battery, this one here. Then we can go ahead to the second current path from your battery to your switch to your relay to your park neutral switch, then to your starter, then back to ground. So here we have the battery to your fuse, to your relay, then to your park neutral switch, then to your starter, again back to ground, negative. So this is also negative. I can also represent it this way. For my case, since for a vehicle it is normally grounded to your chassis or to your body, the body of the car. So since here I have no body, I just wire it directly back to the battery. But for my case, these are can represent it. Yeah. So for the park neutral switch, the car won't start unless it is in parking gear or neutral gear, or for the manual cars you've depressed your clutch pedal. So this is for safety purposes. Maybe when you start your vehicle in gear, it may jump and maybe cause an accident, maybe hit someone, hit something. So it is for that safety purposes. Yeah, it is located at your gear lever, and for the clutch switch at your clutch pedal. So that is the use of this switch. So from your switch to your starter, our starter has two main components. We have the solenoid, this one here, and then we have the armature and field windings here. So let me break it down for you. See how it is. So here we have our field windings. Here we have our pinion. Here we have our armature. Then here we have our solenoid. Your plunger in this plunger in your solenoid is normally connected to your pinion that way, so the armature can slide inside and outside that way. So these are contacts, and this is the current from the battery. It closes the contacts. When the contacts are closed, your current can flow into your windings, then out. So Here we also have brushes. This one is positive and this one is negative. The brushes are at back here. So that is the pinion gear. Yeah. Yes. So here's how it works. And this is back to the earth. That one. Then this one is from the relay or the path neutral switch. So when current is closed, this switch is closed, current flows to your path neutral switch, then to your starter. Flows from the path neutral switch, then to your starter. When it flows into your starter, it energizes this coil, and this coil is pulled inside to that direction. When it's pulled inside to that direction, it closes these contact points, and at the same time it causes this pinion to move outside in that direction so that it may engage with your engine via this pinion gear. It engages with your engine here. This is the flywheel for the manual vehicles, so it engages with your engine here, and this is the drive plate for your automatic vehicles. So the starter engages with your engine here and cause it to rotate as it rotates that way. So after the contacts are closed, current can now flow through your windings and out, and through the brushes and out. Now it causes this to rotate. Now the starter begins to rotate and rotates your engine. That's simply how it works. It's real simple. Current in energizes your coil is pulled in, it pushes out the pinion, your pinion engages with your engine, current then flows to your field and armature and out, it makes it to rotate. So this is how a DC motor works, as our starter is an example of a DC motor. Yes, so as you can see, maybe I can show you how this one is pushed outside. See, it is pushed outside and engages with your engine. So basically that is how the starting system works. If there are any questions, you can ask them at the comment section, and hope you have an idea or you can visualize how it works. So when your car might not be starting, you might want to look at the voltage of the battery. Maybe your battery might be dead. Maybe you might have an open connection. An open connection is there is why your wire may be cut, may be damaged, and causes current not to flow. Your fuse may be blown up, your switch may be faulty, your relay may also have blown, your switch may be faulty, there might be fault in your starter motor, maybe your solenoid is bad, maybe your brushes are worn, maybe there is an your field windings, there's an open wire, maybe your armature. Yeah, so when your car might be starting slowly, your voltage of the battery might also be low, and maybe it might require charging. There might be loose terminals, and there might be loose connection in any of the components, and also your starter might be faulty. So in our case, I used a 12-volt battery, 7 amperes. So this is not enough to start your car. Your car might require a much bigger battery. Yes, so I hope to next week to show you where the components are located in your vehicle, so that you might be able to locate and have a look and be able to visualize well. Until next week, have a great week. Thank you.